Hello everyone. Today we are going to discuss what really is machine learning, and we are going to take a simple example to understand how a machine learns and what all the learning process is, and finally how you use a model. Right? So let's start with the data set. We only have three rows and two data. One is the X, which is our data, and Y, which is the prediction. Okay. So here it's a temperature data set we are taking, and we give that data to something called algorithm. Algorithms are a set of instructions, and there are a lot of open source algorithms out there. We can decide based on our use case. So here it is a binary classification, sunny or cold, which we are going to do. So there is an algorithm and we will see that in action. Finally, when you give the data to the algorithm and run it to different loops, you get a model. The model is actually your output of a machine learning process. This model you can later use for your real world process. So this process of giving your data into the algorithm and building a model is called training or fit. Okay. The second part is you have your new data which you want to give it to your model and ask it to make a new prediction. So the first step, you create the model, and in the second step, with the new real data set, maybe today's temperature you give, and try to make it predict the value of Y, whether it is sunny or cold. This step is called inference or prediction. So let's try to see this with an example. First, we are creating a data set, sample data set, which is the temperatures and the weather. Okay. So in Python, there is a library to print it properly, so we get it as a tabular format. This dataset is really easy, so that even visually or you can understand what would be the learning the model does. So there is a temperature. Whenever it's above kind of 30, it is sunny, and 22 and below is cloudy. That we can itself understand. So it's a very good example to learn what is happening inside. So the only one rule in machine learning is machine learning cannot understand string or text. So here our output is string or text. So we do a transformation which is called fit.transform, which converts our data into 1 or 0. There are different encoding methods for that. The one we are using is called label encoding. Finally, here is where you are doing your actual machine learning fit. As you learn, you are giving your data into the algorithm. The algorithm is called logistic regression, and it creates a model. Okay. Here you go. This is your model. Okay. Now let's use that model to predict for today. Today it's a very hot day, so if you give it, it's going to say it's sunny. Now, rather than just seeing what is happening and the model doing, let's go a little more deep to understand what the model has learned, right? For that, let's try to create a plot. So what we are trying to do is, first let me comment this out. Let's just plot the data. So here is our data. Up to 22, and then 30 is on the other type, right? So ideally, imagine if it could draw a line like this, it would be able to predict the future data, right? And that is exactly what it does. If you see here, this is the line it is going to draw across the data to understand, so that whenever it sees a new value, so for example, when we gave 40, it was able to predict. Now let's try something in between, maybe 36. Okay, so when you give 36, again it's predicting sunny because it's on this range. So what about 16 or 17? Yeah, let's try 17. It's able to predict cloudy. So that's all because of this graph it has learned. So how does it draw this graph? It's based on two parameters, that is its weight and the bias. So for a simple model, there are only two parameters, that is the weight and the bias. Okay. Now let's expand on that. So when it comes to neural network, this is what we saw. A simple logistic regression has two parameters, W and B. But when it comes to neural networks, there are a bunch of neurons which are put together in layers, which gives us lot more parameters. For example, in this case, where we have three inputs and one output, and there are 1 2 3 4 5 6 neurons, there is around 23 parameters. Okay. And the most interesting part is the new large language models, they have around 175 billion parameters. That's how they are able to learn the most complex details about the data. I hope this was interesting, and thank you.